Hello, this is Jack Jackson. In this video, we're going to talk a little bit about some of the required materials we're going to need for college geometry. But before I do that, I want to take a quick look at my newest version of the textbook or notes for the class that I've written. There's a table of contents that are hyperlinked. It has my course policies and procedures at the beginning. We're going to come back to this required materials here in just a minute. Then the first week we'll be going over that and an introduction and early history of calculus and the foundations of an axiomatic system, and just give you an overview of the course. Second week we'll do incidence and finite geometries. Third week we'll be talking about distance, order, between, and we'll introduce four infinite geometries: Euclidean geometry, spherical geometry, taxicab geometry, and hyperbolic geometry. And we'll be using a lot of the course will be exploring all four of those things in parallel to each other. Week 4, we'll be talking about angles. Week 5 and 6, we'll be talking about triangles, introducing triangles, classifying them, and then triangle congruence properties, which is a big heart of calculus, heart of geometry. Quadrilaterals will be the topic for week 7. 8 is more quadrilaterals and parallel lines. And we'll summarize quadrilaterals in 9. So this work with triangles and quadrilaterals and multiple geometries is going to be, in some ways, a lot of the meat of the course, right in the middle. Then we're going to focus our attention on Euclidean geometry and talk about similarity. In week 10, week 11, there'll be some circle theorems. 12 is perimeter, area, volume, and some other topics. We're going to talk about this explore, discover, conjecture, test, prove cycle throughout the course, and then I've got a little section on that. And then we're going to end the course with a section on transformations. At the end of the notes, there's an appendix that is a set of postulates, definitions, and propositions that will be the official list for my class. And this list is there in the order that we're presenting them. And throughout the document, there are hyperlinks to the appendix there. And you can see my contact information there. Okay, so let's go back up to required materials. So in my course now, I'm not actually requiring a textbook. We're going to use these notes as a textbook, and I will be updating this file throughout the semester. I update it a little bit each year. It's mostly in pretty good shape at this point, but I will be making some changes and adding new videos as I go along. However, I do want to bring out a few other textbooks that are very useful. College Geometry, A Unified Development by David C. Kay is the most consistent with the approach that I'm doing, and it's an excellent textbook. If you're going to buy a published textbook, I recommend that one. He also has College Geometry Discovery Approach. That's a little less formal approach by the same author. It's also a good book. We've also used Euclidean and non-Euclidean geometries, Development and History by Martin J. Greenberg. It's particularly good on tying some of the historical stuff in with the study of Euclidean and non-Euclidean geometry. Robin Hartshorn, wrote Geometry, Euclid and Beyond, and Elementary Geometry from an Advanced Standpoint by Edwin Moyse is an older text, but it serves as a basic approach to Euclidean geometry that I used and Dr. K used to write our books. We'll also be studying the novels Flatland and Sphereland. I have some of these dual books like this that we can check out for my students, but they're pretty easily found online. Actually, Flatland is actually in the public domain. It's a very old book. Sphereland is not, but you can buy these as used relatively cheaply if you want to do them. My YouTube channel you're familiar with if you're watching this video. We're going to be using GeoGebra extensively. I'll talk a little bit about that. When you're doing work in my class, be sure you're working in Microsoft Word. We're going to be using the equation editor in Word to get the appropriate symbols for lines and rays and so forth, and line segments and things like that, which doesn't work quite so well in something like, say, Google Docs, which is no, I have nothing against Google Docs. It's a great program, but we have a free version for our students at UA Fort Smith because uh, we have a license to Office 365, so they can get that. A couple other things that you should get. We are going to be using a compass and straight edge and a compass and ruler. So I suggest getting a compass for this class. You want to get one that's pretty good. Here's one link that I found, but I'm not endorsing this particular one, but something along this line, it's this quality or better. I would suggest this one I found for about 12 bucks. I found rulers for as low as $1.50 or so, and basic degree protractors. There's several cheap options that you can go there. A lot of your uh, discount stores, department stores, and school supply stores and office stores. A lot of these different stores have some of these things, or you can certainly find them online as well. So get that. Another thing that I'm requiring my students to do is get a protractor, or actually two protractors, that measure in radians. Radians are really the preferred angle measurement for modern measurements. So we want to have both a degree and a radian protractor so we can measure in either system. And there's a group, a company called ProRadian, and you can see the link there to it. And they have three models. The two that I suggest getting are the ProRadian 2 and the ProRadian Pro. And I was able to order a couple of these, including tax and shipping, for about 11 bucks. If you order them in bulk, you can even get them a little bit cheaper. But here's what they look like right here. And so you can measure, this one's measured out. Each one of these, let's see, each one of these bigger marks is a tenth of a radian, and each one of these little ones is a hundredth of a radian. So this measures for up to the hundredth of a radian, and they're clear, so you can see through them, just like you can with most uh, uh, protractors, and they're plastic. This one has things marked off in multiples of pi over 24, and so you can see some of the more standard angles there. I also suggest we work in pencil in general, and then also maybe have a small box of colored pencils. Doesn't have to be a lot of different colors, but a few colors, the pencils there, and use unlined paper. So just some basic, cheap computer printer or copier paper uh, for this class. And of course, we're going to have our computers for this class, for the videos, for GeoGebra, and so forth. So we're going to have a computer that will work. Um, Now, the Flatland Sphereland stuff, I send my students a PDF of the public domain Flatland, and then I have some copies of Sphereland they can check out, or again, you can order that online. Leonard Sphere kits we will use sometimes. Here's an example of that right here that gives us an actual sphere to do spherical geometry on. It has drawing tools that are similar to Euclidean geometry rules for things like a compass and a straight edge and so forth. Protractor. Um, we may occasionally use some other things. Power solids. Uh, these are really cool. They're set up to help us understand things like surface area and volume and just naming certain shapes. Polydrons. Let's see. There's the polydrons there. They allow us to understand um, nets for polyhedra, and we can see how those work. A mirror or georeflector can be used for doing reflections, Euclidean reflections there. Snap cubes are used for doing various different things in mathematics. They're one of my favorite manipulatives all the way around, and we'll use them for exploring architectural mats. And patty paper is well, it's paper you put between hamburger patties, and it's a kind of a translucent thin paper that you can use for tracing. Um, and so if you're a school teacher, you can probably order some patty paper from an actual um, food supply kind of place at a lot cheaper than you can order it from some other places. But most of these things here, the students will not have to buy. We have these things in a closet, and we'll pull them out for our students. Um, but the notes may refer to them a little bit later. So that gives you a quick overview of some of the things that we're going to be using for the class, and the some of the things that we have in our table of contents. So anyway, I hope you enjoy this class and enjoy these videos and learn some good geometry this semester. Let's have a great semester.